Okay, we're still in right triangles. We just did Pythagorean theorem, some radical work, and now we're going into special right triangles, okay? There's the 45, 45, 90 and the 30, 60, 90, okay? So all we're going to do is focus on this one, the 45, 45, 90 today. All right, if you have a 45, 45, 90 right triangle, then this side and this side are always the same, okay? If this is 10, this one's 10. Okay, if you want this side, this one is actually longer, right? So if you want this side, you would multiply. If you're getting bigger, you want to multiply it by the radical 2. So 10 times radical 2 is 10 radical 2. And I could have done that from here, right? 10 times radical 2 gets you that one. Now, if I wanted to go backwards, then I would divide by radical 2 if I'm trying to get this short side. Say I didn't know this was 10. Okay, so I would take my 10 radical 2 and divide by radical 2, and look at that. They cancel, and I get my 10 back. Okay, so that's all there is to 45, 45, 90. You either multiply by radical 2 or divide by radical 2. If you're small and trying to get big, you multiply. If you're big and trying to get small, you divide. Okay, so let's look at this one. All right, this one's 4, so we know that this one must be 4, right? And BC here is 4. And then if we want AC, then that's getting bigger, so we multiply by radical 2. So 4 radical 2 would be your answer. Okay? Here, 18, this one's 18. This one is, of course, 18 radical 2, right? Multiply by radical 2, you're getting larger. Okay, so AB down here was 18 and AC was 18 radical 2. All right, and then here's one that's a little tricky. We would multiply, right? Okay, this one's 10 radical 2 still. Okay, but we would multiply by radical 2, right? So let me do it up here. 10 radical 2 times radical 2. Remember what we talked about before? Outside times outside, and of course the number on the outside on this one is 1, so 10 times 1 is 10, and then inside times inside is 2 times 2. If I have a pair, I can cancel and bring one of them out, okay? And the radical disappears, right? There's no more radical, right? So 2 times 10 is 20, okay? So CT is 20 and AT is 10 radical 2. All right, here's one where I'm starting with the hypotenuse and getting smaller, right, to get the other short sides, which are going to be the same, okay? So I'm going to take this one and divide by radical 2, right? Those cancel, and I get 20 and 20, okay? As I can see, I'm going to need my calculator. I'm going to run and get it. I'll be right back. Coming back. Got my calculator. All right. This one is the 90. That's a 45. These two are the sides that are congruent. Even though it doesn't look like it, that was the hypotenuse. That's the long side, right? Okay, so the long side is the 11. And so what I want to do, if I want to get shorter or smaller, then I have to divide by radical 2. So 11 divided by radical 2 is not going to work out to be a whole number, so it's going to be a decimal. So we're going to say, let me get this over here. Okay, so 11 divided by second x squared is radical 2, and hit enter. And then 7.8 is what we're going to put. So 7.8 here and 7.8 here. Both of these are the same. Okay, this one right here, this is the long side, right? These are the short sides. If you got two 45s, you know that's a 90, right? Because these add up to 90. 180 minus 90 is 90, okay? So that's 7, and then if you want to go here, it's just so quick. 7 radical 2. Because you're getting bigger, you multiply by radical 2. Remember, you either multiply by radical 2 or divide by radical 2. That's it. Okay, so JH is 7, and SH is 7 radical 2. And I like for you to leave it in this form. You don't need to like punch it in and turn it into a decimal. This is the exact number. That's a nice number right there. Okay, number 7. Okay, this is the long side, right? If they want the two short sides, we know that they're going to be the same. So we need to multiply or divide. Yeah, we divide. So we take 22 and divide by radical 2, and that one's going to be a decimal. So we say 22 divided by second radical 2, bam, 15.6. So both of these are 15.6, okay? Now, this one right here, is this a 30-60-90 or a 45-45-90? We don't know, but we do have two sides. Don't forget this stuff. This is from before. This is the Pythagorean theorem. This is the adding Pythagorean theorem, right? You have two legs. You want to find the hypotenuse. Remember the little shortcut I showed you, the a squared plus b squared? Okay? So you plug the 6 squared plus the 8 squared, take the square root of it, and if you punch it into your calculator, you'll get a 10. Okay? So if you have 2 out of 3 sides, you use the Pythagorean theorem. Okay? Here's 2 out of 3 sides, right? Okay? Anyway, is this the adding Pythagorean theorem? No, it's the subtracting Pythagorean theorem where you go c squared minus whatever the other one is. It could be an a squared or the b squared, it doesn't matter. As long as you put c first. Okay, so the hypotenuse you always put first or it'll give you an error. Okay, 13 squared minus the 5 squared, and you punch that into a calculator. Guess what? It's going to give you a 12. Okay, so 13 squared minus 5 squared is, whoops, you got, uh-oh, man, I made a lot of mistakes on that one. Okay, second radical 13 squared minus 5 squared is 12, like we were saying. On to the back, that's 12. Okay, on to the back. Okay, some application type problems. If it's a square, all the sides are equal. They want the diagonal. Okay, well, one thing that's nice about this, I mean, what did we do before? What did we do last time? We said this was 10 and this was 10, and we did square root of 10 squared plus 10 squared, and we got the answer, right? Remember? Okay, if it's a, we know those are 45s, right? If it's a square, that's got to be 45s. So couldn't you just say, bam, 10 radical 2 and you're done? Okay, because it's short sides, getting the long side multiplied by radical 2, and I'm done. I'm done. I'm so done. Okay? All right. Here's another square. Okay, the diagonal 16. How do you find a side? Well, all the sides are the same, so you can go backwards, right? Getting smaller. So since this is a square, you know that this triangle is a 45, 45, 90. So you can divide by radical 2. Okay? All right. So 16 divided by radical 2 is a decimal. Okay, 16 divided by second radical 2, bam, and I get 11.3. Okay, so both of those sides would be 11.3. All right, perimeter and area, okay, of the square. Okay, so all the sides are the same, so I just need to find a side, right? So 14, okay, 14, this is a 45, 45, 90 since it's a square, right? Okay, 14 divided by radical 2, right? So we get 14 divided by radical 2, and we get 9.9. So the length and the width are both 9.9, and that's an approximation, of course. And then the perimeter itself is 9.9 times 4. Well, we'll just take that times 4. Why not? Times 4, and that'll give us 39.6 for the perimeter. Because perimeter is just all the way around, so we multiplied by 4, right? We took that 9.9-ish thing and times by 4. Okay, the area is base times height, right? Or length times width, whatever you want to call it. And we know that those numbers are the same, right? So 9.9-ish times 9.9 is 9.9 times 9.9 is 98.01. Okay, so we'll say it was 98, and since it was centimeters, we'll say centimeters squared. Okay, right. Did everybody get that? Yeah, there you go. Okay, so we need the area and perimeter of this. All right, that's a 45, so guess what? If that's a 90, this has got to be a 45 as well. You add them, subtract from 180, you get 45. Okay, 6 radical 2, if I want these sides, which are going to be the same length, right? Because it's a 45, 45, 90, I'm going to divide by radical 2. They're going to cancel, and I'm going to get 6 and 6. So the length and the width is 6 and 6. Perimeter, 6, 6, and 6 radical 2. So 6 plus 6 plus 6 radical 2 is, I don't have much room here. Okay, let's just do this and say that it's 12 plus 6 radical 2. That is the exact answer. Okay, that's exact. All right, so if it's exact, that's good. All right, and you could change it to a decimal and combine it all and get an inexact answer, but that's okay. So area of a triangle is base times height divided by 2. Remember that? Okay, this is a base, this is a height. The nice part about having a 90 is it doesn't matter what it looks like. You've got a base and a height, and you multiply them together and divide by 2. Okay, so 6 times 6 divided by 2 is 18. And did they give us inches? Yeah, inches squared. Okay, anyway, we're done. All right, have a good day.